So a couple of lessons learned, some pros and cons. So the pros are that CPM allows us to focus attention on a subset of critical tasks. It allows us to determine the effect of lengthening or shortening the critical tasks on the overall project completion time, and it links particular task durations to the overall schedule, right? So how does changing the completion time of a particular task would impact the overall project? It's an important question to know, it's an important question to analyze. CPM allows us to look at these type of situations. What it does not capture is iterations. In fact, cycle errors are specifically prohibited, right? So what is a cycle error? In which we say that the dependencies are such in which A depends on B, B depends on C, and then C depends back on A. This type of interdependency is not allowed. You cannot model that, okay? So, however, we recognize that iterations are essentially part and parcel of projects. They're essential features of development projects, right? So when you're doing something for the first time in particular, you are likely to iterate, you're likely to do things over again. So this is very much intrinsic to real world projects. And to reiterate what we just talked about in CPM, so far what we've covered is a project in which the task relationships look something like this, right? And what if we wanted to put an arrow from 5 back to 6? That is not allowed, right? So what to do? Well, there are methodologies in place, and DSM is one such method. So what DSM allows us to do is to look at coupling, interdependency. So far what we've discussed is the serial relationship between tasks, right? So A and B are in series. We've discussed the parallel relationship here, represented here. So A and B are parallel tasks, as shown in this figure. And now we're going to talk about a situation in which we have something like this. So A depends on B, and B depends on A, okay? So we have this iterative relationship, okay? So that's enough of a background. So now let's get into the details of DSMs. A DSM essentially, it's a two-dimensional matrix representation of interrelationships of different types of entities. Those entities may be physical objects, so components in a mechanical system. Those entities might be tasks that comprise a project. The entity might be teams, groups of people who are interacting. So it's a very general way of representing relationships between different types of entities, right? So let's go through and see how a DSM is actually constructed. So we're going to start with the project graph, and we've all gone through and sort of worked our way in understanding what this represents. So it shows how the tasks are interrelated. We're going to convert this project graph into a matrix representation, into a DSM, okay? And I'll walk you through the different rules that apply. So the way to read this matrix, so this is a two-dimensional matrix, right? So you have rows here and then columns on top. So these are rows going from A through H, and then columns going from A through H. So each row and each column essentially is associated with a particular task, right? So there are H tasks, so you have an H by H matrix, right? So a matrix that has H rows and a matrix that has H columns, okay? And what you now do is essentially you start from the columns. So starting with A, you can see that A feeds into B and A feeds into C. Or you could look at it row-wise and say that if you look along the row, what you'll see is essentially the set of tasks on which this particular task depends on. So if you look along the row of A, you see that A is not dependent on any task. There are no X's in row of A. But when you look at row B, what you find is an X in the A column, meaning that B depends on A. So now if you sort of go through and fill out the matrix, what you essentially do is represent the same information that is captured in this picture into this matrix. And this is the dependency structure matrix. So this matrix is telling you how the tasks are interdependent. It's the same information, there's no additional information there. It's just that the representation is different. Here you are representing using nodes and arcs. Here you're representing that information in a matrix using rows and columns. Okay, so what's the point? I mean, why do we care? Well, the matrix representation has a lot of advantages. One is that you can do a lot of nice and nifty linear algebra, which is a whole branch of mathematics dealing with operating matrices, right? The other aspect is that it allows you very easily to represent something like this. So now if you have a case in which you want to represent an iteration, so task G goes back to task C, you can very easily put in a check mark here. So you can see that in this row for task C, we have an X corresponding to G, so C depends on G. It's a very easy way to now represent and include in your analysis this iterative behavior of elements. So here was our original DSM, okay, A through L. And is there any particular sequence to how the rows are organized? What's the sequence? Alphabetical. So right now, it's just an alphabetical sequence. They've organized from A through L. Is that the smartest way or the realistic way of organizing things? Not necessarily so, because the tasks may have been labeled in an arbitrary fashion, right? We saw that when we were drawing the graphs. I mean, you have the letters all over the place. Once you identify what the interdependencies are, they don't follow an alphabetical sequence, right? So the first thing that you do when you are looking at a DSM and trying to analyze this is to put it in the right sequence, or to conduct an operation which is called sequencing. And what this procedure does is that it essentially puts the rows and columns in a particular way such that all the serial relationships are neatly organized, and any iterations that may exist inherently in the relationships become obvious. So now you can see the letters are all jumbled up, right? But you can see that the overall matrix has assumed a particular neat structure, okay? It has cleaned up in a way, and it is also giving you new information that was not obvious here. Here everything was just scattered because it was just alphabetically, written. But now after conducting the sequencing exercise, you can see that there's a certain structure that has appeared in the matrix, right? In how the X's are organized and so forth. So there are different strategic decisions that you are now better able to make once you understand how at the system level, at a higher level, are things interdependent or organized.